Thank you, Peter, for the for your kind introduction. I'm Kazuhiro Gomi, and we are one of the new industry partners for the Simons Institute. Glad to be a part of it. And so let me just give you a quick introduction of NTT Research. We started out our operations about a year ago, and then became the part of industry partner for Simons Research since then. These are the areas that we are doing the research at the NTT R&D Center in Silicon Valley: quantum computing, crypto, and information security, and the medical informatics. I'd like to focus on those first two, quantum and crypto side of the house for this presentation quickly. So for the quantum computing side, the type of research that team is conducting is focusing on basically quantum annealing type of machines, using that fiber optics and basically laser oscillator, optical parametric oscillators, and then we basically run the short pulse of lasers, and then we just control that pulse of laser using those delay lines here. And then we have implemented that initially just the delay lines, and then now we're using the more sophisticated logics to control the delay, using those FPGAs and based on machines, and then reinsert the pulse depending upon the calculated the delay. Now, with this machine, we have done a couple of simulations, and then this is initial results that we see. So that the graph here, that the comparison of with the D-Wave machines and then the CIM, which is a coherent Ising machine, that's basically the machine that I have just shown you, that composite of it. So as you see that the CIM is showing a pretty good performance so far. So we continue working on it to add more, understanding this mechanism a little better, and also certainly adding more the spins to be able to solve more realistic problem. Switching a gear, I just give you a quick recent work that the team has done. I'm going to introduce three the recent works. The first one is that the chosen ciphertext security from injective trapdoor functions. This was presented at the Crypto 2020 in August, and then chosen as the best paper from there. Basically, this is to resolve the problem that was outstanding for more than 30 years, that how to really create the secure environment, secure calculations based upon the core function of PKE, public key encryptions. This core function is injective trapdoor functions, and then create the security level of in the CCA2, which is the strongest security challenges. So and then basically the team has worked on this and then proved that you can construct this type of securities. So that's the work that the team has done. And the second thing is that the title indistinguishability obfuscation from well-founded assumptions. So this is the team has tackled on the obfuscation program, and basically to address the indistinguishable obfuscation. And there were some many people I understand that have been working on it, and then can you make that I/O using a program side? And this paper have proven that based upon it has proven that I/O can be constructed from the well-founded assumptions. So that's the new another recent achievements coming up from this team. And last not the least, that from the this cryptography and information security team, they're working also on the blockchain analytics, and then to understand the blockchain mechanism and so on and so forth. So this particular work that the team has done with regard to the blockchain is the following. So basically, the problem set that the team is looking at is that something like Bitcoin, that the blockchain with proof of work. And when you look at the blockchain, Bitcoin, the situation right now, that there are many, instead of individual doing the minings, that each individual typically join the mining pools. And then those mining pools are becoming larger and larger. So one may think that those mining tool will be super big, and then will gain more than half of the shares of this blockchain mining activities, and which creates the centralization risks. Basically, if one party have the power more than 50%, then that may basically can break the block. So that's kind of the problem set that the team has working on. Now, for this particular work,
2 minutes.
Thank you. For this particular work that has approached this problem by applying the game theory to this problem, and then as a result, it was found that to maximize that return for each mining pool's perspective, they should just maintain that 10 to 15% of the shares. And then if you go above and beyond that, that should really adversely impacting their profitability or the return. Therefore, based upon the game theory, that the share will be standing, share of each mining pools are standing somewhere around 10 to 15%, which is actually, when you look at the real status of the Bitcoin, that's what it is. So it's kind of being proven from a theoretical perspective. So these are the just examples of recent outcome from NTTs, and if you are interested in learning more or discussing more of those things, just let me know. I can happy to connect you to each researcher. So thank you very much for your time.